It is Monday, March 23rd. I hope you had a good weekend. Took the weekend off, and it's nice to have you guys back here. I have Norman with me today for our lesson, or Norm. He's a good boy, an old good boy. And he went cross-country skiing with me this weekend. He's a little tired still from it because he's an old dog. All right, today we are talking respiration events, so how air gets in and out of the lungs. Your lungs aren't like a vacuum. There's nothing like physically pulling air in. It's mostly just due to volume pressures, high to low, and diffusion, high to low. That's it. That's all that's moving things in and out of your lungs and in and out of your bloodstream, which is pretty cool. So we are going to just be on the last page of your study guide today, page 10, very back side. We won't even fill all of this out. Hopefully it'll be pretty short and sweet for you. So as you can see on this picture, we're going to move through these different steps of respiration and define what each of these things are as air is moving from outside your body to into the bloodstream and into the cells is the eventual place we'll get to at the very, very bottom here. So starting off with pulmonary ventilation, this is a very fancy word for breathing. All it means is getting air in and out of your lungs. And so when we talk about breathing, we use the fancy word at least, is pulmonary ventilation. So if you've heard of ventilation and stuff, these are machines that are allowing air in and out of the lungs for someone who maybe their muscles aren't doing the job for them. And the thing that lets you breathe is your muscles of your rib cage. The ones that allow you to inspire or inhale is when air is entering the lungs. I don't have it on here, but you could add inhale as well right here. That's another word for inspiration. But is the diaphragm, which is the muscle right underneath your rib cage. When you breathe in, your diaphragm drops down, which allows air to rush in. The other thing is your external intercostals. So your intercostals are all of the muscles in between the rib cage, and it goes all the way to the backside. And when you breathe, you flex those muscles, and what they end up doing is they end up spreading apart your rib cage. That action makes your chest cavity bigger, your diaphragm drops down, and your rib cage gets bigger. All of this increases the lung volume, the volume of this space inside of here. Compared to the outside, so the air all surrounding you, this allows then for air to rush in because air, just like all other things, likes to go from high to low pressures. High pressure out here. When I make room in my lungs, I've made a low pressure system by increasing my lung volume, and air rushes in. There's a diagram showing this at the video you guys are going to watch after this. Expiration is when air exits your lungs or you exhale. That might be another good thing to write down right here under expiration. When the air exits the lungs, we call that an exhale. Now, you can exhale passively. You probably are doing that right now unless you're actually consciously thinking about breathing in and out. But all that is relaxing the two muscles we mentioned up above. So relaxing the diaphragm, it pops back up. Relaxing those external intercostals, they kind of collapse back in. Inspiration, expiration, everything gets small again. This decreases my lung volume and air exits my body. Now you can also do a forceful expiration. To do that action, you might even feel your body tighten. What it is not the external intercostals, but the internal intercostals, and they're pulling forcefully your rib cage back together to make it smaller and tinier. If I said exhale all the air you had in your body right now, you feel your body kind of collapsing in on itself, getting tinier and tinier as you decrease your lung volume. That is a forceful expiration. But normally you are just breathing passively. So moving on to external respiration. Respiration is usually referring to when the oxygen and carbon dioxide are getting into or out of your bloodstream normally. Okay. So in external respiration, the air still isn't in my body per se because it's not in my bloodstream. So that's what external respiration is about. It is about blood moving from my alveoli, the little sacs inside my lungs, to the blood capillaries that surround those sacs. Those blood capillaries are called the pulmonary capillaries because they are the capillaries in and around my lungs. If you remember from cardiovascular system, this was a picture you guys had to annotate and was on your test. We talked about the pulmonary circuit. So when I'm talking about these pulmonary blood capillaries, I'm talking about these guys right in here, as opposed to the systemic capillaries in your systemic circuit. So during this process, carbon dioxide, which is in a high concentration in my blood capillaries, is leaving the blood and going into my air sacs, my alveoli, and oxygen, which is in a high concentration in the air around me, is moving into my capillaries. The way it does this is just by simple diffusion. There's no gatekeeper saying you in, you out. My body just knows I want more of the stuff I have less of, and I want to get rid of the stuff I have more of. So things are always moving from high to low. Oxygen is high in the alveoli, low in the capillaries, it moves in. Carbon dioxide is high in the capillaries, low in the alveoli, it moves out. Nothing forces it in and out. It's just diffusion, which is awesome. This section we're going to skip for now. It's important information we'll go over later, but we're going to talk about where and what the blood and the carbon dioxide hang out in when they are in the bloodstream. And so that's what this is all about and how gas is transported throughout the body. But I just want to talk about the events of the respiratory system. So the last step on kind of this bus station stops that we're making through the respiratory system, we got air physically into my air passageways of my lungs. Then the oxygen moved into my blood capillaries. My circulatory system is going to move it throughout my body. And eventually I get to the cells I want to drop it off at. This is internal respiration when oxygen is going to move from the blood capillaries of my systemic system. So that area, wherever it is in the body, my big toe, my brain, my elbow, who knows, it's going to drop off the oxygen and pick up the carbon dioxide at the systemic blood capillaries. So the oxygen moves into the interstitial fluid. We oftentimes like to say it moves into the cells, but before it goes into the cells, it goes into the space surrounding your cells, and that's your interstitial fluid. And so then from the interstitial fluid, it can move into my body cells. So the oxygen, simple diffusion again, is just going to move from the capillaries into the interstitial fluid and then into my cells. Likewise, carbon dioxide, which is in high concentration inside the cells, is going to move into the interstitial fluid. From there, it's going to move into the blood capillaries. And then my heart is going to help get it back to the lungs where I can exhale it through expiration. Those are the events. That's it for the lecture video. However, I do want you to go back to Plan Book, click on the assignment or the things to do number 2 and watch this video. You can fast forward to about 4 minutes and 30 seconds and just pick up from there. You don't need to watch the entire thing, but if you've got the time, might as well. It's not bad stuff. If you are ever if I'm moving too fast and you're like, oh, I didn't get that written down, obviously you can pause the video, but I've also shared this exact same PowerPoint I'm using right here for you guys. It's in your Google Classroom. So if you get into the file, the stream, and just scroll down, every day I post an assignment, it shows up there. But if you scroll down to March 19th, I've got the study guides for this unit if you didn't come in on Wednesday last week and pick them up. But I also have the PowerPoint. It's the exact same PowerPoint I'm using right now. So you can open that and then at your own pace and own leisure go through it. As you look through this PowerPoint, though, I would recommend watching it in present mode because I have things kind of flying in and out. So some pictures might end up covering up things that you need to get written down in some cases. So present mode tends to be a little bit better in case I've got stuff that are covering up other labels. But you can obviously figure that out. Anyways, Norm was not snoring through today's video, although he is sound asleep. I hope you guys have a great day. Miss you guys.